And then I'm going to mute my mic and turn off my camera. That way you guys are in
turn off mine.
Total control. Take it away, sir. You have the floor.
Perfect. Awesome. Well, thank you guys so much for having us. Let me figure out how to share my screen real quick so we can see what I'm looking at. There it is, share screen. There, can everyone see the screen now?
You're good.
Roger,
Good.
Yes. Yep.
Perfect.
I can see it. Yep.
So today we've got a really exciting topic. You know, a lot of what we're going to cover today, I think everyone has probably heard about, you know, individually at some point or another. But I think it's kind of putting all of these individual puzzle pieces together in one cohesive thought, and how we approach this at the beginning of the repair that really makes a really big difference. So before we get too far, before I get started and start rambling, I just want to introduce myself just in case you didn't catch the last webinar from 2 weeks ago. If you didn't see that one, you definitely missed out. We kind of covered some ADAS and using the wand to kind of verify where that ADAS is. But my name's Avery Hodge. I am the sales coordinator here at the Matrix Wand. Joining us today, we also have Sergio Correa. He's our director of training and technical support. And we are lucky enough to have a good friend of mine and a mentor, Roger Cada, joining us today from Accountable Estimating. Roger has been a figure in the collision world for a while now. So before I kind of butcher his background, I'll kind of let Roger kind of give a quick recap on his bio before we get started.
Sure. Thanks, Avery. I'm Roger Cada. I've been in the business now for a little over 50 years, so I am a dinosaur. But at the same time, I stay on the cutting edge of things by working in the industry at cutting edge points. That's where I know Jason and Kristen so well. And so my point is that I worked in the collision industry for 15 years as a hands-on technician and shop manager, both independent dealerships. Went to work for a large insurance company with 3 red ovals, and worked in the Chicagoland area for about 6-7 years. And then I was put into a corporate training position, for which I did that job for 25 years in downtown Bloomington. So anyway, retired from them in 2015, and I began Accountable Estimating to build estimating training online through the AMI platform. So with that said, take it away, Avery.
Hey, Roger. Well, thanks so much for taking the time to join us. You know, it's really cool. You know, I've seen you in a ton of trainings. I've always seen you in a bunch of videos online. So to finally be able to kind of work together and put this presentation, it's really been an honor. So thanks for taking the time. You know, the first thing that I kind of want to start off with is something we hear all the time, and it's they just don't make them like they used to. And really, thank God that's the truth. You know, Roger, can you kind of give us a little bit of background about this picture? I'm sure we've kind of all seen it in the past.
What you're looking at here is an image of a 59 Chevy crashing into a 2009 Malibu to take a look at how they both reacted in a collision, because we used to hear that all the time, that the older cars are built for strength and today's new cars are just weak and they fall apart. And actually, it's just the opposite. The older cars really had no strength whatsoever. There was a fatality in that 59 Chevy that you see there. And in the 2009 Malibu, the driver would have just walked away with minor scuffs and bruising. So that technology that's in that 2009 Malibu has gone even further, because now we're in 2020. And so there's been huge changes and huge leaps in safety and technology. And the whole car today, I want to make this point real clear. The car works as a system. Everything on that car, as opposed to that 59 Chevy, is there for a reason. Not only for aerodynamics, not for good appearance, but also for safety and functionality of that car. It has to meet all kinds of Federal Motor Vehicle safety standards, as you can see here. You have small overlap, frontal crash, side crash, rear crash, roof crush. All these are Federal Motor Vehicle safety standards. And what the car companies are also dealing with is the lightweight the car, maintaining the strength and crash worthiness, all while trying to meet an objective of 54.5 miles per gallon. But that has changed recently. But the car companies are not going to back off. The goal is that they still have to meet lightweighting objectives to meet the CAFE regs to sell cars in the future in 2025. So with that said, that's going to play into a lot of the reasons we're going to do different things differently as we get into the topics. So Avery, you want to talk about that?
Yeah, so like you said, with the car being approached as a whole system and all these new technologies resulting as different objectives, from cafe standards to pedestrian safety to all these new sensors and materials, it really leads to a lot of challenges and opportunities at the shop level. We've always relied on gaps as indicators of structural damage. It's been the first thing that draws our eyes. I'm sure everyone on this call, when you're sitting at a red light and you're looking at the car next to you, I do it all the time. You're looking at the gap between the fender and the door, and then the gap between the door and the rear door. It's just natural, but they're not as reliable as they used to be, and it's for many different reasons that we're going to kind of get into here. So we really need to start diving into these OE repair procedures. That's where we're going to find all the vast of knowledge. I know that's what's being pushed down every channel. I know we talk about it here on Collision Hub a lot, but we have to start there when we start talking about these structural repairs, because that's where we're going to start finding these steels. They can change from year to year between, there doesn't have to be a body style change for the steel to change. So we have to dive into these procedures. It's also going to kind of give us a hint on where we need to look when, load paths and where we might find this damage versus where it might have been in the past. And then we need to take all of this information that we're capturing from these repair procedures, and we need to know how to apply that to the actual structural repair. It might not always be super straightforward. There might be some OEM procedures that might make something look that has traditionally been a really easy gravy job be 3 times the amount of work that we actually think it is, and we could be working on a total loss and not even know it if we don't start capturing this data up front and determining the life cycle of that repair. So obviously these challenges are having impacts on the repair. We're missing a lot of opportunities on structural repair. I think, Roger, you can give me the exact statistics, but it's like every estimate has the average of 0.2 on frame time, and that's not paying for anyone's frame machine at all. It's leaving a lot of unidentified damage, and that can create unsafe repairs. It can create something that was a really easy repair from us from that first initial impact, and if we don't approach that right and repair it correctly, it can lead to a secondary accident that was way worse than that original incident. And because of all these complicated systems and technologies, we're seeing an increase in cycle time, and it's becoming more and more difficult to identify these damages and these potential total losses up front. It's just throwing a whole wrench into the system. So Roger, you kind of went into this earlier about gaps, but they kind of still are useful. So when you're first approaching a car and you assume it might have structural damage, what are your eyes looking for? What are the first things you're thinking in your mind?
Well, the first thing I want to look for as I approach any vehicle is how was that car impacted. But we'll get into that later to make more details of that. But as Avery said, the next thing I'm looking at is how does everything fit up. And in the past, we used to be able to use these gaps very efficiently because they were attached to something of the structure, whether it be the quarter panel or the fender bolt of the apron. They were attached to something structural so that when the structure moved, it would take the panels that were on the outside attached to it and misalign them, buckle them, distort them, or change the gaps. And gaps today really are not as trustworthy as they once were. Now, some car companies still tell you to check the gaps. Audi's one of them, BMW. But we want to take a look at this further to see why it's important that we don't always trust these. The first thing we have to take a look at is how was that car being designed? And today, and this is going back like 8 years ago or better, cars started to incorporate pedestrian safety, meaning that if they had a cyclist or somebody crossing the street, that the person that they struck would not be fatally injured. And so by doing that, they had to find a way to soften this car in the front without impacting the crash worthiness, but yet still be soft enough where it might not kill the individual that they struck. So how are they doing this? One of the first methods that they came up with is they wanted to make the front softer by softening up the hood so that it collapsed like a catcher's mitt, so it would capture that person that they just struck. Or if their body hit the fenders, it would allow the fenders to collapse so that they wouldn't have these serious injuries. So they put fender perches between the fenders and the aprons. As soon as this happened, what happened then is that the structure moved. We would not see any gap alignment. In a lot of cases, the fenders or the The hood would sit exactly where it was in an undamaged position, but yet we still had structural misalignment. So if the car was impacted in the bumper beam or the hard structure, chances are it might have moved. And so we had to find a way to analyze damage, and we'll talk about that later with measurements.
So all of these changes, great news for the cyclist, great news for the pedestrian crossing the road, and really great news for the occupant themselves. But I mean, as far as after the fact, when we have to go and fix these things, it's really creating a big headache. So Roger, where kind of the first place you go to kind of see what features this car might have? The first thing I think of is I always want to turn to the OE repair procedures. I know I was already harping on that at the beginning of the presentation, but I think that's just the first thing you need to do. That should be your first knee-jerk reaction, is just dive into those repair procedures, because every car, even the same model, is going to be different year to year.
So that's a great point, Avery, because a lot of times I've talked to repairers out there and they think, well, I'm going to pull these up when I start fixing the car. No, the time to pull these is when you begin to do your damage assessment of the vehicle. And so you need to know how that car was constructed. So number one, you can identify the areas of movement that were created from the impact that you're looking at, and then what metals are being used in those areas, and are they repairable type steels or are they one-time use? And so with that said, pulling up these diagrams at the time you're creating that assessment will be critical to the decisions that you make as you start fixing that. Now think about this for a second. If I know that certain parts of that car can never be fixed, that means that I need to have those parts available when that car enters production. And so if I don't have them, now my cycle time, as Avery mentioned earlier, will be damaged. So, and that's a bad thing. So pulling the OEM procedures is critical to getting an outcome of success.
Yeah, and we continue to see these metals change. Year after year, it seems like we're seeing more and more non-repairable metals enter the market, and not only are they being introduced more and more frequently, we're seeing them, on different parts of the car as well, which is making more things challenging.
Correct, Avery. The steels have been changing on the car since the 1990s. As a matter of fact, Jason was involved in some of this stuff years ago when he was with iCar. And so iCar was looking at these things. This group of people, which is a consortium of steel manufacturers, started to look at how they could redesign steel so it could become the most prevalent product on the car. But they had to lightweight that, but maintain strength. This has basically generated new forms of steel that we've never seen before, and we may even come across even newer steels in the years to come. But my point is that you can see to the right side of that dotted line, that's where a lot of the newer stuff exists. Take a look at the stuff on the left-hand side, and you'll still see mild steel. The BH that you see there in the green oval is bake hardened, which has been used on Ford products on some of their outer body panels since the 90s. You will also see HSLA, high strength low alloy, or high strength steel. Those are still being used in today's cars, and it doesn't mean that they're not repairable as long as they are in tensile strength less than 600. So if you take a look at these charts here, you're going to see, number one, that today's cars, and that was back in 2018, there was over 200 different steels being used on the 2018 models, 200 different steels. You take a look at the chart to the right, you'll see an arrow there, and there's a dotted line. Anything on the left-hand side of that dotted line, which is usually around the 600 figure, on some car companies it might be a little higher or a little bit lower, but it's not much. 600 is about the average. On the left-hand side, repairable with some limitations. On the right side, non-repairable. So we need to know what's going on with the tensile strength as we identify these steels.
Yeah, so as we start seeing some of these areas of the car move, and we can identify the steel, then we can kind of figure out, okay, what exactly needs to go on with the car? What can we expect in terms of repair? But now we're starting to see these steels, traditionally only being in a few places of the car. They're kind of popping up in more areas of the car as well, Roger. It's not just right near the passenger compartment to keep them safe. We're starting to see it, all the way, in that front rebar.
That's exactly right. And so if we take a look at this image here, you can see that they've highlighted it, and also one here. These steels are being used in places that we never thought we'd ever see them, but they're being used, and it's not to challenge you, the technician, but it's there to build safety in for the occupants of the vehicle and the pedestrians. So if we take a look at these charts here, this actually came out in 2017. I'm trying to bring you a little history in here. But prior to 2017, we had cars being built where the advanced steels were mainly in the center section of the car. And the center section there for just for passenger safety. But in 2017, things started to see a different move. It was shifting these steels out to the front and rear of the vehicle. You can see that some of the trucks out there were using an advanced steel bed. Some of the trucks were also using in the shotguns, as you see in the center diagram up there, which is part of the aprons. They were using advanced steels too. Now, if you take a look to the chart to the right, you're going to see Fortiform and a number to the right of that. You'll see numbers such as 980 up to 1470. This is the tensile strength of those steels. And as we discussed earlier in the previous slide, anything above 600 is non-repairable. And so yes, so we want to make sure that if we see damage in those areas, we know that we have to replace it, and we have to look up the OEM installation procedures to know how far we're going to go into the vehicle. Now, if you take a look at this chart here, and this one happens to be Ford, but General Motors makes one, Chrysler makes one, and basically all the car companies do, but this one was nicely laid out, so I selected this one. And what it's showing you here is in the top part of the chart, you'll see in the second aisle, the second column from the left, it said trade descriptions. It'll actually have the tensile strength of the steels. It tells you what kind of welding techniques you can apply to that steel. It tells you if it's repairable, if you can use heat, and then it gives you opportunities for repair versus replace. But once you get this green box and go into the steels below that, you're going to start to see things become non-repairable. In this case here, they have a dual phase steel, which is the first one there. It's a DP 500. And once again, even though we gave you a general guideline of 600, that doesn't mean you just use that. You have to go to the OEMs, because if they have their DP 500, that means that you follow these guidelines. You don't mix them between car companies. You don't mix them in a general statement. You try to find the specifics for each year, make, and model, and by production date.
So Roger, now that we've kind of taken in consideration, looking at the gaps when we approach the vehicle, we've pulled up the OEM repair procedures. We've identified the metals that are involved, so we know what metals on the car we can expect to fix, what metals we're not going to be able to fix that will have to be replaced. Now it's kind of where can we expect to see the damage? You're talking about some of these metals are designed to absorb a lot more energy. Some of them are designed to kind of keep the occupant safe and are a lot stronger. So they're going to start absorbing these impacts differently, and we're going to start seeing the damage in different areas. The tool that I think that we use the best to kind of to find where to expect this damage is definitely load path. I think this is probably one of the most underutilized tools that we have at our fingertips that are available for a lot of vehicles. Roger, how do you kind of approach the load path?
Well, you want to have this diagram when it's available, and then the car companies will have them for front impacts. Some will have them for side impacts or rear end impacts, or even rollovers. It depends on the car and what's available to you. But it's important that you know this before you do your damage assessment, especially if you're going to pre-measure the car, because this is an example of a load path diagram of a car that I was out at a repair shop looking at that had an impact just to the bumper at the bracket area where it mounts to the left frame rail. What was interesting about this car is that it had been in the shop for over 60 days. And they found out that not only was the frame rail slightly out of position, but there was a large buckle on the bulkhead right behind the brake booster. And the question that everybody was asking is, how did it get there? So when we went and pulled the OE procedures and took a look at the paths, as you see there, in the grayed area, the grayed circle box, that you're going to have loads going from that impact to that part of the vehicle. So if we don't have the diagrams, the road maps that tell us how that car is going to transfer damage from that impact, we're going to miss opportunities. And what we talked about earlier about safety is if we leave distortion in structural parts of that vehicle, it will not perform in the same safe manner as it did when it was undamaged. Meaning you have just added crush zones from the first impact that were not considered in the repair. This is where it comes into safety. So we have to know where to look for the damage, and that helps us. Now this one here is on a Civic, And this one here is showing you that they used to use this, the frame rail alone, if you look at the bottom diagram. But now they have figured out that they want to use the cradle, the engine cradle as well. And so they're taking that engine cradle now and they're bringing more damage back into the bulkhead and the toe pan of that vehicle. And so unless we know these things and we know where this damage may go, we don't know what to measure. This is going to help us.
Roger, this can happen with, without a body style change. I mean, it could be, a matter of 2020 versus 2020.5. This could happen in the middle of a production year where they introduce a new metal.
That is correct, because they're constantly trying to advance that car, and they're not doing it yearly in some cases. They're doing it mid-year. This is why production rates are critical when you look up the OEM repair information. And it's also critical that even if you fixed one of these cars 30 days ago and you looked it up and it's the same year, make, and model, you do not trust that repair information. You are always going back to pull fresh data, because the car companies are constantly changing and they never let us know exactly what that is. They just do it. So if you take a look at this Jeep, for example, here, now this Jeep has a lot of mild steel and high strength steel in it. It's not the advanced steels that you expect. They use some of it in this Jeep, but not everywhere. But take a look at the load paths that are in this vehicle and how they incorporate everything to make that vehicle safe in the event of a collision or a rollover. And so if you take a look at, for example, the side impact on the diagram on the right bottom of your screen, you're going to, right above the Wrangler sign, you're going to see that when the impact comes into the car, it can go forward and it can go backwards. So unless I know these things, I don't know what to measure and where I'm going to find that damage.
So now we can kind of start applying these concepts into real world. It's one thing to kind of look at some of these OEM repair procedures, especially as we start training our guys to pull these open for every single accident, every single vehicle that enters the shop. It can get confusing. They're throwing a lot of information at you. Just looking at the load path, there's all those arrows. They're going different ways. You're not sure what to make of it. But when you break this down and you look at the actual vehicle, it's not that hard to kind of put the facts of loss together and then kind of piece everything together kind of like a puzzle. I think it's just a matter of taking that time and actually doing it, and not just relying on the facts of loss that you get from the bill payer, the insurance provider, really drilling the customer and finding out exactly what happened. Maybe in a simple accident just like this one on the screen, there could have been more than one impact. Maybe they slammed into them, hit the brakes, and then slammed into them again. You kind of need to know all of that when you're going to find out where the structural damage might be.
And that's a great point, Avery, because fenders, hoods, that's easy. That's easy to analyze that damage. When it comes to structure, I think a lot of us on this presentation are going, where do I start? So the first thing is gain good information on the facts of the loss. Find out what kind of vehicle struck what vehicle, how did the accident take place? Because then when you take a look at the damages, let's say on that white car, here's the questions you're going to start asking. If it went under a larger vehicle like you're seeing here, where it struck the back of this SUV, we know that we're going to have that bumper height they're not lined up. So that bumper in the rear is going to go over the bumper on the white car, and it's going to push things rearward. So if you go ahead and you think about that, if I start taking measurements and the specifications say that I need 1,500 millimeters to measure from this point from the bulkhead to, let's say, the core support at this point, I'm going to probably see, based on this impact, something less than 1,500 if damage exists. The other thing to consider, too, is that if this bumper on the white car went under the other vehicle, so I have an underride, then the damage from that weight of that vehicle could push that structure down. So I'm going to have to do measurements that consider downward movement as well as length movements.
So, Roger, traditionally in the body shop industry, when we talk about measuring, especially when we talk about measuring for structural damage, it's always been underbody. That's where we focus. We've always gone for the frame rails that's where it's always centered around. But as with more of these systems and the vehicle working as a whole, we need to start kind of approaching that same mentality of measuring for the structure under the body and the other quadrants of the vehicle as well. One of the biggest ones I think of is side body, just because there's always been that question. We've always approached this with a little bit of doubt. Where is that B pillar? How far is that B pillar pushed in? Where is that width? There's never been a really great way to accomplish this. With traditional measuring systems, maybe you have to build a whole structure if you want to compare from one side to the other and get actual measurements. And then on top of that, there's not really 3D data from the OEM manufacturers on where exactly these points are in 3D space when it comes to the openings. So really, we need to kind of be more inventive on how we kind of approach these. But it's extraordinarily important because we've got a lot of high strength metals in these areas for safety reasons.
Well, good points here, Avery. And so here's the thing: if you think about it, if these cars work as a system, and we need to measure more of them because we don't actually see all the damage through the indicators we once had in the past. We don't want to tie up our production area, and so having a tool that's versatile that we can take to the vehicle regardless of where it's at, whether it's in a stall, outside, or down the road, we can actually measure that car, but with this tool that's quite versatile. By doing side-to-side comparisons, basically considering that everything on one side of the car, the undamaged side, is symmetrical to the side of damage, now we can do comparisons. Now, this is a project here I was working on for Honda at the time, and so what we were looking at is a side impact. It damaged the front door pretty severely. The question was, is a striker in the right place on the B-pillar? And also, since it hit the rear door pretty bad and tried to drag it rearwards, we were concerned about that lower hinge location. And the reason we were concerned about that is not because the aperture had a slight amount of a little bit of movement. It was the question of, is the inner structure damaged from this impact? Because if it is, we have to disassemble the side of the car to reinstall the ring that goes in the front door opening, so it has this crash worthiness again. So you're going to say, well, you mean that little amount of movement and a reinforcement needs to be replaced? If the car companies say it needs to be replaced, that's exactly what's needed. We don't even question it because we are not the engineers to know that since that piece of metal has been compromised, if it'll have the same resistance in the second loss. So we have to measure that. So we did that. And as we compared the measurements from side to side, as you can see in the green lines above, we were plus or minus 2. So plus or minus 3 is the tolerance is given by Honda. And so we felt like we were good to go with, and knowing that that B pillar was where it needed to be.
So in this example, all of the damage was superficial, but now we've got that documentation to prove it. If there's ever an instance where it came back, the car was returned, they're hearing wind noise or something, they're still complaining. Well, we can easily pull up and see that structurally, we didn't have any inner movement there. It was all superficial. So we know there must be something else. Maybe it's the door. Maybe we got a bad door if we used a used assembly. We can go ahead and start checking these off and finding what the true problem is.
And you mentioned wind noise there, Avery, too, is that if I fix this vehicle and I take images with the matrix, that if the car has questions that come up at a later date, 6 months or a year or 5 years from now, I can still use the matrix software to go back into the images taken with the matrix wand and measure the car either in the damaged position or doing a post-repair image if that's part of the processes for the business. So I can measure to validate, did the car leave my business with everything in the right place? And that's one of the beautiful parts about the matrix that I like, is because not only does it build evidence for the moment of the damage assessment, but I can also return to those images at a later time and measure things again if necessary.
Sure. So in this next example, it's very similar to the last one where we've got an impact and we're not quite sure about the door opening. How severe is that damage? Obviously, we can tell this in this example, it's a lot more a force than the last one. But here we went ahead and picked some of those pinch weld areas to compare to the other side because we know they'd be connected. We don't want to necessarily have to disrupt the body technician to come out and cut an opening, a hole, so the estimator can do his job and write an estimate. Why not just give him the tools to do this all up front, out in the parking lot, so he can write that full and complete estimate. And if by chance it happens to be a total loss, then we've got that right up front. We could do that, within a few minutes of the vehicle arriving on the lot. Roger, you there?
I'm here. Yep.
Sorry.
So let's go to the next slide.
Yep, absolutely. So the other area that definitely gets overlooked when we talk about structural damage is under hood. You know, with all these new metals absorbing collision differently, and kind of like what we talked about in the last webinar, when it comes to ADAS, we've got a ton of sensors now being attached to the front of the car. So just a few millimeters of shift, of misalignment can really put someone in danger later down the road. We've got the sensors looking 300, and now some of them are looking 600 feet down the road. So just a little bit of misalignment can really create big problems down the road. So we need to make sure we capture those up front. But again, it hasn't traditionally been as easy to get some of these measurements, especially in 3D. But you know, what we need to do is really start off measuring point to point. That's really going to start telling us right up front what we can start expecting to see. These are simple 2D measurements, kind of like what you would do with a tram bar, but with the wand, it's a little bit on steroids. So it gives us the ability to measure through direct objects and start doing this really quickly and documenting that process as well. Roger, can you kind of walk us through this example?
Sure. So if we take a look at the numbers that were created on this, you're going to see there's an X mark there, or cross check. And what we basically did is we took a look at the yellow line or the orange line, depending on what you're viewing there, and the green line. And we took a look and focused on those two things. So we saw that the yellow and the green, one was 1522 and the other one was 1526. We had 4 millimeters of movement there, but we had to find out what the specifications were. And so one of the things about the matrix is that I can go ahead and click at the top. There's a little diagram window up there. And by clicking on it, I can pull up the Mitchell data to see what they came up with. And as we take a look at the Mitchell data for that measurement, they have 1524. So we're plus or minus 3. We're good shape again.
So it's kind of like, Roger, when we're approaching these under hood and upper body measurements, we're kind of taking that same classic approach that we have with the lower body measurements. It's kind of like measuring a full frame vehicle. You want to find those trusted measurements first. You know, in a full frame vehicle, when we're measuring the frame, we always start with that center section and square that out, and then we start working our way out from the torque boxes. It's a very similar approach here that we want to apply. We want to find that trusted area that we can you know, find and build off of. So here it might happen to be those strut towers, but sometimes, you know, the vehicle is just slammed in the front and you're not even sure if you can trust those strut towers, or maybe it was a little bit of an overlap hit and you've got some suspension damage and you think it might have pushed that strut tower up a little bit. You know, we have to start thinking outside of the box, and maybe you need to go further back into the vehicle. So go up the A-pillar to where it meets the roof and the windshield, and maybe we can start measuring from there down to the front of the vehicle, since we can measure through objects down to the front rails. We just need to become more inventive so we can find these trusted areas so we can start working out from there.
So as you take a look at this image here, you can see that there was a pretty hard impact in that left front corner, and we were concerned about that strut tower moving. And so we didn't know if we could trust that piece. So we went deeper into the car to an area that we knew that was designed for safety and strength, which was the windshield opening. And we picked the corners of the windshields and the body. We've done this in many other measurements on cars, and it's a very trustworthy area on that vehicle. And so measuring down to the rail tips, we were able to determine if the damage was isolated to the apron, or was it did it do some things to the frame rails. And so by doing this check here, we found that we were perfect on the frame rails. We were plus or minus 2. And so we knew the frame rails were fine. We were going to focus our attention now on the apron of this vehicle, since it took a pretty good impact.
So yeah, so now once we've been able to find those trusted areas and we can start building off of that, we can take these 2D point-to-point analysis and we can now look at this in 3D. And I think this is where it really becomes important, because those 2D measurements can really hide things. Just looking at the X and Y coordinate, it can hide a lot of damage. And that's kind of what we see here. Like you said, we were in spec when we were looking at 2D and we were crossing things out. But when we add that third coordinate, that's where things start to get interesting. On this car, it happened to have that impact on the passenger side, point number 9 and point number 7. And there really wasn't that much damage. It looked really just like maybe a bumper cover repair, but we couldn't find any actual physical damage on any of the pieces on the radiator support, on that upper tie bar. Nothing that we would have been able to take a picture of and send in for any time. But then when we go and we look at the 3D measurements, we can easily see there that there's some sway, that it's pushed in 6 to 7 millimeters towards the center of the car. That wouldn't have been captured up front. That would have been missed. We would have probably had trouble fitting the parts on at the end of the car. We probably would have been able to get it done, but it would have caused a lot of frustration. There would have been unrepaired damage on the car, and it could have potentially affected the ADAS of the car, you know, down the road. And we didn't capture that on the estimate. That was just missed. That was missed revenue.
One of the things that I always hear is that, you know, how can we trust this? I mean, where's the science behind this that shows that by using an image and using the pixels in the image that we can actually get accuracy with going from point to point or in a 3D type world?
Yeah, Roger, you know, we briefly went over this on the last webinar when we talked about ADAS and how the wand works, but it's based on that principle of photogrammetry, where you know, all the way back to Leonardo da Vinci, we kind of talked about that. But really where the magic happened is where we took that photogrammetry and we applied it to digital photography, and we call it stereoscopic imaging. This was really developed back by NASA about 30, 40 years ago when they were trying to measure stars out in the galaxy. They wanted to see the distance. So what they did is they took multiple images from different telescopes, and they're able to kind of layer those on top of each other and use triangulation to measure out that distance. That's the exact same principle that we use here. And so you're technically measuring pixels. You're assigning kind of a pixel to that image, to that area of the car. So down at the very bottom of the slide, we can kind of see that little bar here within that red circle. We can go ahead and actually take the image out behind it and just look at the pixels we're measuring. This is very similar to what, you know, that they're doing when they're measuring stars. This almost actually kind of looks like a constellation when you're looking at it, the little green dots being stars. So that's kind of the technology behind it, you know, coming directly from NASA. You know, and Roger, you know, the last area of the car that I really want to focus on today is the rear body. I think this also gets looked over. There have been a lot of changes. You know, we don't necessarily use spare tires as much as we did in the past. So there's been some kind of construction differences with that. We've got newer metals in the back, and we've got, just like we've got ADAS sensors up the front, we've got ADAS sensors now being applied to the back of the vehicle as well. So it's more important than ever not to overlook these simple rear end hits. Something that might look like a gravy 3 or 4 hour bumper job might actually have some structural damage right behind there.
You know, and if you think about this for a second, if I can take measurements before the damage assessment is created, or I can take images to do a post follow-up, meaning I'm following up to see what everything looks like before it goes to paint. Now I can make sure that I'm going to have a successful outcome when it does go to the paint shop. Plus also, too, it builds a record for the business so that they don't have to concern themselves with that they didn't do the job right. And so and like Avery said, the back of the car is becoming more challenging because they're removing spare tire to reduce weight for better fuel economy. And by doing that, that spare tire in the past was considered part of the crush worthiness of the vehicle. And so they're now using advanced steels in floor pans, frame rails, and even rear body panels to provide that energy management on a rear end impact. So measuring these things and knowing what the OEMs say is going to be critical to getting the right outcome.
And even if we're using a tram bar to kind of tram some of this out, it can still be a little misleading. In this example, you know, everything looks like it's in spec, 668 compared to 666, 1211 compared to 1212. It looks like it's squaring out just fine. That looks like it's in spec. You know, we can easily compare these to the reference data like you recommended, and then we can take it into a 3D analysis. But when we take it into that 3D analysis and we add that extra coordinate, that Y coordinate, in this case the MASH, we can see that there's definitely a problem. There's this point number 7 on the top of the rear body panel is mashed in 7 millimeters, but we couldn't pick up on any of that when we were just looking at 2 of the coordinates. It was hidden. It averaged it out for us. So, you know, I think the lesson to take away is we can't trust things like we used to, and it's becoming more and more difficult. We need to dive into these repair procedures. We need to see the metals that are being used. We need to see, you know, where to expect some of these damages. So Roger, you know, kind of, you know, to recap this, you know, the first thing that you're always looking for, you're going for those gaps. even though they're not as reliable as they have been in the past, it's the first thing that's going to start leading you down that path. And then you can dump into those OE repair procedures to figure out what kind of seals on the car, what the load path looks like, where you can expect that damage. And then finally, break it down step by step. Don't overcomplicate it. Try to apply it as simple as possible to the repair. Roger,
Correct.
Is there anything you want to kind of add on to the end of that?
No, there's a whole lot more to understanding this. And so one of the things we're doing at Accountable Estimating is we are building online courses that will take a learner from beginning to end and how to assess structural damages, how to have discussions with people who are paying the bills, so that this way here, everything is going to work out better, because we're going to see more structural movement. We're going to see the need to measure vehicles just because of the things that they've done to the car in the last 5-6 years. So these courses will be coming online, coming soon.
Well, Roger, thanks so much for your time. Quickly, I want to give everyone some quick updates in case you missed last week's webinar. If you've seen the wand in the past, even as recently as the last trade show that we've attended, we have some new updates. One of the biggest one is how the wand looks. So we've changed the physical appearance. It used to be gray. Now it's this really pretty red that you can see on the left side of the screen. An update that we released over the last year in different sections has been Fender Bolt. That's the new version of our repair analysis software. It's cloud connected. It gives us the ability to support our customers a lot better with different training options and the ability to jump in and give them technical support right on the system. We can take over control. You've already taken the image. We can help you walk through it step by step if you're running into issues. It also provides those shop owners with usage reports. So if they want to see and track the ROI, how much the lawn is being used every week by which users, how many, what years, make, and models, they can quickly jump on and track that data. We also just recently changed that blueprinting station that used to be a light gray cart. Now it is a little bit bigger. It's got a little bit more workspace. So it's great if you've got other technology in the shop. Maybe you're doing your own calibrations or you've got a scanner. You can easily keep everything all together and have a true technology station. It comes with that 32-inch monitor, so you can run 2 programs simultaneously. Maybe you throw the Mitchell repair or the Matrix repair analysis software up top, and you've got an estimating software down at the bottom, so you can write the estimate and do the measurements at the same time. So it gives you a lot of versatility. One thing that we mentioned in that last webinar that was a big hit with a lot of shops who took advantage of it is our online training. So we've just offered some free online training. Fender Bolt comes with this already preloaded for all of our wand users, but what we've done is we've modified a version of this for everyone who doesn't have a wand. So if you don't have a wand, if you're not affiliated with Matrix in any way, you can still go to fenderbolt.com, register with that code MTX2020 and your iCar ID number, take a modified version of our training, get an understanding of how the wand works, and we'll pay for your iCar credit. So it's worth 1 iCar credit when you use it without the wand. We'll go ahead and cover that cost so your technicians can use some of this downtime in the shop as the shop is slow and go ahead and rack up on some of their iCar credits. That's on us. We just want to keep the industry moving forward. And of course, once you're done doing that, go ahead, reach out to us. Let's schedule a demo. You can really see what the wand is about. We really just kind of scrape the top of the iceberg here when it comes to the actual applications and what the wand can do. So let's get a web demo scheduled, but at the very least, take advantage of that free iCar credit and get your technicians logged on and signed up for that ASAP. But other than that, Kristen, thank you so much. I guess we can go ahead and open it up to some questions.
Bam, you guys rocked it today.
Thank you. Thank you.
Yeah.
There's a lot of info to throw out there.
I was taking notes. I was like, damn. Okay. Fingers hurt, boys. All right. So chat room, if anybody wants to post up a question in the chat room, or if you want to unmute your mic and ask anything while you got the guys there. I started learning I thought I knew estimating, and then I got my first real estimating class in '95 from Roger Cada. So ask this man any questions you got while you got him on the line.
Thanks, Kristen.
Mr. Bartnan, are you there with us?
I'm here.
Hey, you have any questions? He's the brains of the operation.
I don't know what to ask. You know, loosely.
Awesome.
Well, yeah, if we don't, well, guys, that web demo, it's about 45 minutes. If your shop is currently closed and you guys are kind of scattered, we don't have to wait for everyone to be in the same place. Reach out to us. We can gather all the email addresses and just kind of do a group demo all together. That's one of the great things about the wand being so software driven is we can do a pretty thorough web demo online and kind of show you all of those great features.
Yeah, it's an amazing blueprinting tool. It doesn't take a lot of training to teach somebody how to get up and on it, and going with it. It does once you do get your training, you do need to use it. That's what I have a lot of shops call me back and I go, look, you took the training. Now you got to go out and find stuff to measure. Even if you don't think you have it, just go measure something. So,
No, it's true. And then the more you measure with that tool and the more you let your mind expand and just say, wonder if it can do this. That's when you really start to see the power of that tool. Because, you know, you can do suspension and upper body and lower body, and you can measure your ADAS components. And it just never, the whole process never stops. As a matter of fact, we had one company out there that was looking at, once they've set up the calibration boards, the specifications by the car company, could we measure the placement of those boards to validate the recalibration? And the answer was, yes, we can. So it's basically endless of what you can do to document. And keep in mind, this is building evidence that justifies your charges to get a profitable outcome and also too, it's confirming what the car needed and also confirms that it was corrected properly. So there's a lot of opportunity here.
Yeah.
Roger, I'm glad you mentioned the ADAS piece and the verification again. For those of you that weren't able to watch the previous Matrix Wand presentation, the previous webinar, definitely check that out because we covered exactly that, what Roger's talking about right now. And I think the thing that ties us all together, again, these advanced steels and new materials that we're working on, the steering suspension Roger's mentioned, the ADAS system, they all work together, especially, again, more than ever today when it comes to the ADAS systems and making sure that those ADAS systems function as designed, because they are very, very, have very, very small tolerance on these ADAS systems. So we need to make sure that we're putting the vehicle structure back in the proper location, the suspension in the proper location, and certainly all those ADAS cameras and sensors in the right location, so that it all works together. And it's really important that we're putting all those pieces back in the right place.
Excellent.
Yeah, Jason, you bring up, you know, all those points that you mentioned there. One of the questions I get asked a lot is, when should we use the Matrix Wand? What cars should we measure? And it's, you know, I just tell everybody, every car that comes into a collision shop should be getting some type of measurement, because you said all these different systems work together, the ADAS, the suspension, the structural. And so we need to be able to find all of that. So really the answer is every car needs to be measured. And obviously that can be very difficult and time consuming, but using the Matrix Wand, we're able to now be able to achieve that a lot quicker. And there again, documenting it at the beginning, during the repair, and at the end if we need to.
It is a great tool. So I go back and watch that first webinar if you missed it. And then obviously this one will be up for available for replay. Takes me a couple hours to get it up on the website. So if you missed the first half of it and you want to go back and watch the rest, or if you want to send this out and share it with your people, it'll be on that channel. And then we're back. I'm sorry.
Someone's asking if they can get that promo code again. Avery, can you put that screen back on?
Yeah, that is MTX 2020. MTX 2020.
Excellent. We have a super jam-packed week next week. I can't even, and it's getting fuller. So it's some great stuff. So we're going to start it off. We'll kick it off Monday morning at 10 a.m. Central Time. AccuDraft is going to be here talking about all the things you could be doing to your paint booth right now. If you aren't still running full cycles, etc. Some things you can be doing for maintenance and upkeep on your paint booth. And then we're also going to break down a daily, weekly, monthly, kind of yearly schedule for making sure that you're keeping that thing in optimum pressure, optimum cycle. So that's going to be a great one. And then Mickey's back with us at 1 o'clock Central on Monday to talk about relationship marketing and community-based marketing, relationship marketing plans. are some of the best things you can do as a collision repairer to grow your brand and grow your incoming car count. So you're definitely not going to want to miss that one. Guys, I appreciate your time taking it on a Friday for us. And if you have any questions for Matrix or for Roger, you can both get them online. Roger, did you share your information?
That would be at the first slide up there in
Okay.
the front, but you can reach me at accountableestimating.com. And if you need to get an email out to me, you can reach me at Roger, R-O-G-E-R Cada, C-A-D-A, at accountableestimating, that's all one word, .com. And I'd be more than glad to answer your questions. Thank you,
Excellent.
Kristen and Jason, so much for this opportunity. It's great to see you guys again. And
Yeah.
look forward to the next
You
time.
too.
Maybe, I don't know when we're going to actually see each other again. This may be the new normal for how we see everybody. So virtual high fives
Exactly.
to everyone. And y'all have a
Yes.
great weekend, and we hope to see everyone for real very soon. Thanks.
Absolutely.
Thanks,
Take care
guys.
now.